Okay, I'm gonna go through the. Oh, you can't see that. I'm gonna go through the pictures that I took of the work you didn't understand on the waves. Okay, I'm gonna do it on my whiteboard. So ignore how I look. But so the diagrams are. Can you see? Okay. This B is same like that. C it's like that. D is like that. I'll flip it so you can read it. But I thought they're covered. This is the midline for each of them. So this is just me trying to replicate. Oh my god. A graph. Okay. Question 7 is what kind of waves? No, I don't have to write that out. Actually, I'm not doing that. What kind of waves? Your options are transverse, longitudinal, sound, or shock. So it's not shock because we didn't learn about shock. It's not longitudinal because that's the longitudinal waves. Is this shit? Or it's like, oh, it's this, and then it goes to this. You know, those are longitudinal waves. Which is what you answered. You answered longitudinal, so that you just mixed that up. The right answer is transverse waves. That's literally if it looks anything like this, if it does this sort of thing, it's transverse waves. Oh wait, you answered? No, you didn't answer longitudinal. That's my bad. You answered sound. I read it wrong. You answered sound. I mean, technically, yeah, but sound waves are just a type of transverse wave, so the broad is transverse. What is the wavelength for figure C? So that's this one. This one. This is blurry. Sorry, I'm trying to figure this out. So the equation, wavelength equal, what is the equation for wavelength? Hold on, 1 second. Wavelength, so lambda V over F. Can you read that? It's a really bad F. Sorry, I'm like, there we go, F. We want wavelength for C, so I'm gonna try my best to read this. I might get it wrong, but you'll get the gist. Does it tell you? Shit. Okay, wait. Give me 2 seconds. Like, skip past this part. Hold on. I need to get my... Cow. Okay. My bad. My bad. Okay. Hang on. I need my notes. I forget. Okay, I did get that part right. Hold on. I can't read what yours says, so I'm gonna look at mine. This is good, and have it help me figure out what yours says. Oh, what is the wavelength? Oh my god, I'm so stupid. So, because it's asking for the wavelength and we have a picture of the diagram, you don't even need to do an equation. I was overthinking it. So a wavelength is this, okay? It goes up, so this part is 1. This is 1/2 right here. So it's up, down, up is when it has to hit this part. Has to hit the x-axis twice. So this whole thing is the wavelength. So whatever the length of this whole thing is, up, down, up, and like this, the wavelength would be, you could start right here on the x, up, hits the middle, goes back down, and when it hits the middle again. So that would be the wavelength on that. Hopefully that made sense. I tried. The frequency of figure B. So the equation for frequency is F equals 1 over T, where T is the period. So, period is, so the period for this one, what did I put for that? Hold on, sorry. I low-key am blanking what a period is. Oh, a period is one wavelength, I believe. Yeah. So a period is the exact same thing. That. What I just explained. So if you find the period for your oh my god, sorry, this keeps getting dark. For your figure B. No. A. Oh my god. I skipped a question for you. We'll go back. So this is period for figure D. Bang. That whole thing. I can't read the units on yours. The period for figure D on yours is 10. So it would be 1 over 10 is the frequency. That's just knowing how to plug things in. And then the amplitude for figure A, you said it was 4, however. So I'm going to label this for you. This is the axis 0, negative 1, 1. That's a vibe of what it goes up to. So the amplitude is from the midline, how long it takes to get to, I'm trying to make you see, so how long it takes to get to this crevice, the top. It's absolute maximum. So it would just be 1. Because it's not the full thing. It's literally just getting up to this absolute. Radio waves traveling through air can best be described as which type of the following waves? You said transverse. Honestly, I'm pretty sure it would be long. Did I? No, I got that one wrong too. So I don't know. I'm sorry. 13. Okay, let's erase this stuff because we're done with this now. I'm just gonna erase this. Oh my god. Okay. Okay. Stop getting dark, bro. I'm not even looking at it for that long. So I need to turn this sideways so I can see. A physics student redoes the resonance lab and uses a tuning fork of 15 hertz. So, 512 hertz. So the frequency equals 512 hertz. If the temperature of the air is 22 degrees Celsius, I'll let you see this. I can kind of see. I'm trying my best. And the speed of sound in the air. So velocity air is 344 meters per second. So I have to keep looking back to make sure it's not getting dark. What is the length of the tube, the water above the lab? So the length tube. Question mark. Okay. These are the variables that we know and what we're looking for. Did I have? Okay, mine was very close to yours. So first, I labeled everything, and you need to find, to be able to find the length, so the equation for length is, okay, remember? Okay, the wavelength equals 4L. L. This is what we're looking for. We're looking for this L. So this is the equation for it. But to be able to solve this equation, right now we don't have any of the variables for it because we're looking for the L and we don't have the wavelength yet. So first we need to find the wavelength. Oh my god, it's getting dark. Okay, first we need to find the wavelength. So the equation for the wavelength is velocity equals lambda times frequency. To solve for the wavelength, you just subtract f, frequency equals v over f, and we have v of the air, 344, and we have the frequency is 512. So wavelength equals 344 meters per second over 512 hertz. And then just solve for that. I'll solve for it. Hold on. Calculator. 344 divided by 512 equals 0.671875, and you can round. I just don't like rounding, TBH. Okay, so now that you have the wavelength there, you can plug it back into this equation that we found earlier to get the L, which this equation was in the reminder thing, right? So since we're looking for the L, you could do 0.671875 equals 4L. Divide both sides by 4. And then L is going to be whatever you get for this answer. I'm not doing that math, honestly. But yeah, you have to do the two equations. This one's given to you. This one, I mean, you're going to have to find, but it's all going to be on the paper. So you just need to know that you need to find that you only have the one variable here, so you need to find the wavelength with the wavelength equation. That's the hardest part of that, is just knowing that you need to find that. Okay, let's go back to your... Alright. If the tube in the resonance lab is 0.172 meters long, when a 480 hertz tube is placed up to it, what is the speed of sound? And then... Okay, yeah, mine was very similar again, so we're going to erase this stuff from the last problem. Okay. So we know that the length is 0.172. And we know that the frequency is 480 hertz. And we're looking for the speed. So we're looking for the velocity. And we know that velocity equals the wavelength times the frequency. It's another wavelength. This is the equation we used in the last one. So you just plug those in. Whoa, hold on. It's pretty much the same thing we did last time, but just different variables. So right now we're looking for the V. We have the F, it's 480. So before we're able to solve for this V, we have to find the wavelength with the equation that it gives you of wavelength equals 4 times the length. So just plug that stuff back in again. 4 times 0.172, that's the number that it gives us, equals whatever that equals. Let's figure it out real quick. 4 times 0.172. So that equals 0.688. You take this 0.668, plug it back in for the wavelength here in this equation. So it would be 0.66. No, I said it wrong. 0.688 times the frequency of 480 hertz equals your velocity, and that's what you're looking for, is the velocity, the speed of sound, the velocity. So that's how you do that one. All right, and then 15. So this is a really long video. You can just like skip parts and whatnot. But the whole page of stuff is gonna take a second. Especially because I have to remember everything because I have no idea. Okay. So, oh, I'm sitting funny. A cubic glass, which is Ng equals 152, has a light fall from it, from air, and A equals 1 at a 35-degree angle. What is the angle of refraction of the glass? Okay, and I'll draw the drawing for this too. Oh my god. Sorry, I'm moving a lot. Okay, this is 15. So I'm gonna draw us our box. So this is the drawing that was on the test. Okay. And we'll alright. And it gave us that this was 35 degrees. This is theta 1. 1 is outside of the box, 2 is inside the box. So we're looking for theta 2. Okay. And our equation for this, because we have the ends, it gives us the ends, it gives us one angle. Oh my god, sorry, wait, this is the wrong, I was going off mine, not yours. You have a different number. You have 28. My bad, G. Outside the box and 1. Alright? So we have theta 1 and all the ends. So we're looking for theta 2. Our equation is N1 sine theta 1 equals N2 sine theta 2. So you just need to find this. It'll be easy because any of the refraction stuff has the N, and any angle is going to have the sine. So just find that. And we're going to plug our numbers in. So your air is N1 because the air is on the outside, you know. Air isn't going to be in your diamond. This is your diamond. Air is not going to be in your diamond. It's going to be out because duh. So your N1 is going to be 1 point, I'm just getting this from your equation, 1.00 sine 28, oh my god, if I could write, Jesus, sine 28 equals, your N2 is going to be 2.42 of the diamond, sine, and we're looking for theta 2. This is what we're looking for. Okay, so at this point, it's just, you have to do the algebra for it. What did you do wrong with it? Oh yeah, you just used only one side of the equation, you need to use both. Do the math real quick so I can show you. 0.00. Nope. Oh my god. I hate this. This is so stupid. Sine times 1. Sine 28 times 1 is 0.2, we'll round that to 0.271. So that's this side. You plug that straight into the calculator. Equals 2.42 sine theta 2. We need to get this alone, so you divide by 242 on both sides. Divided by 242. 2.42 I meant. My bad. 0.271 divided by 2.42. So then you're going to get sine theta squared equals 0.112. And then to get this theta alone, you're gonna multiply both sides by the inverse of sine. So then it's gonna be, you're gonna press the second button, the sine button. How do I do that on this? I don't know how to do that on. Stop. Huh. This is. I don't know how to do it on this calculator. There we go. Sine 0.112. Okay, whatever. You get the inverse sine of that. So then theta equals whatever you get for that. My calculator's being weird, so I can't tell you. But I hope that made sense. Okay, so that was page 1 that you wanted. I'll make the page 2 in a second. I just don't want to send you it all in one video.